Hi and welcome. I hope everyone is okay. As you remember, in the last lesson, we had worked out an example and worked on this example. We have fair coins. We have fair coins and these coin tossed. Our results are success and failure. So as you remember, failure. And as you remember, we have two worked out. So its situation related to binomial distribution. Binomial distribution. So we have we had worked out the expected value and variance, and we learned the expected what we work out the expected value and how we work out the variance. In this situation and notice, we can use in the binomial distribution and the same process for the same process and in the binomial distribution. And now the random variable in worked example can also be expressed using notation for the binomial distribution. As you remember, in this example, we toss three times coin. So it's we want to come the tail and the binomial distribution three times and the probability of tail 1/2. So success, the probability of success is 1/2. The probability of failure 1/2. So this example related to binomial distribution and this process we can use in this process we can use in the binomial distribution examples. Okay. Now the as you remember, in the binomial distribution the expected value nu, or the expected value n times the probability and variance, or as you remember, sigma square means n minus n multiply probability multiply q. Q means the probability of failure, so 1 minus p. Okay. Now therefore we can conclude that for a random variable x and constants are a and b, expected the ax plus b or expected value, we can also write and work a multiply ax and ex and plus b. But as you remember, in the variance we use if we use a, so we should write a square multiply variance, and also we apply the random variables that have a binomial distribution. And we have an example about in the binomial distribution for using expectation and variance. Now as you remember, in the first value means n, in the second value is the probability value. So q means 1 minus P, so Q 1 minus 0.4 and 0.6. And if you want to work out the expected value, the x o expected, so n multiply p, and 20 multiply 0.4, it means 8. If you want to figure out the variance, it means n multiply p multiply q. So 20 multiply 0.4 multiply and 0.6, and it means 4.8. Okay, now and as you remember in the for the last lesson, if we want to figure out the 5x minus 2 or expectation, the expectation of 5x minus 2 means 5 multiply the expectation of x minus 2. So we figured out the expectation x, it means 8. So 5 multiply 8 minus 2, it's just 38. And if we want to variance of 5x minus 2, if the variance of 5x minus 2, as you remember, we should notice that 5 multiplies, but and if you remember, minus 2 doesn't affect or doesn't affect the variance. So we should write 5 square multiply the variance of x. So 25 multiply and you know the variance value is 4.8. 4.8. Okay, and it means 120. It means 120. And we have more an example. This example in your textbook and practice section, ninth question. Over a long period, the average temperature in an area of Mauritius is 24.5 Celsius. The variance in temperature is 2 Celsius. So in the expectation, for the expectation, Celsius expectation, it means, you know, average or nu. So 24.5, and the variance of Celsius is 2. Okay, using the conversion, Fahrenheit, the Fahrenheit equals to, you know, 1.8 multiply Celsius plus 32, where F is temperature in degrees Fahrenheit and Celsius is the temperature in degrees Celsius. Work out the average temperature and standard deviation in the degrees Fahrenheit. Okay, we want to work out the average, but in degrees Fahrenheit. So we want to figure out the expectation of Fahrenheit. You know, Fahrenheit equals to 1.8 multiply Celsius plus 32. So I can write this section instead of the Fahrenheit F. So the expectation of 1.8 multiply Celsius plus 32. It means, 1.8 multiply the expectation of Celsius plus 32, and we can write 24.5 instead of the expectation of Celsius. So we can write this situation 1.8 multiply 24.5 and plus 32. Okay, now I want to use my calculator. 1.8 multiply 24.5, it means 44.1 plus 32, it means 76.1. And if we want to figure out the variance of F, we can write 1.8 Celsius plus 32 instead of the F, because F equals to 1.8 multiply Celsius plus 32. So if you as you remember, only 1.8 multiplies affect the variance, and plus 32 doesn't affect the variance. So it means 1.8 square multiply the variance of Celsius. 1.8 square means 3.24 multiply variance. Our variance value is 2. It means 6.48. 6.48. Okay. Now we will pass the other section in the our topic. Our topic related to sum and difference of independent random variables. Let we have two tetrahedral dice. A green dice, numbered 1, 1, 2, 3. A blue dice numbered 1, 1, 2, 2. And what will be the mean and variance of the total when the scores on the two dice are added together? How are these related to mean and variance of the scores on the two individual dice? Okay, we will interest this situation in this lesson. Let the random variable G be the score on the green dice. In the green dice, the dice is numbered, 1, 1, 2, 3. So we have two ones, and the probability of 1 over 2, or 2 over 4 actually, and we have 1, 2. So the probability of 2, 1 over 4, and the probability of 3, 1 over 4. And the expected value, as you remember, the expected value of G 1 multiply 1 over 2 plus 2 multiply 1 over 4 plus 3 multiply 1 over 4. It means 1 3 over 4. So the variance, our variance formula means the sum of g square multiply probability minus the expected value of g square. So our variance 11 over 16. And the other dice, in the other dice, B or other named blue, and we have the expected value 1 over 2, and our variance 1 over 4. And I want to write again in this area the expected value of green and the expected value of the variance value of green, the expected value of blue, and the variance value of blue. The expected value of green 1 3 over 4, 1 3 over 4, and variance 11 over 16, 11 over 16. For blue dice, 1 over 2 and 1 over 4, 1 over 2 and 1 over 4. Okay, now the table shows the possible outcomes of rolling both dice and adding the scores. These numbers about green, these number about blue. So 1 plus 1 2, 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, and going on. And if we want to filling out the table, for example, W means green plus blue, and we have 4 times 4 times 4, 16 situation, 16 outcomes. So we have 1 2 3 4 4 twos. So the probability of 2 4 over 16, 4 over 16, 4 over 16 means 1 over 4. Okay, now it's here, and we have 1 2 3 4 5 6 threes. So 6 over 16, so it means 3 over 8. This is here. And if we want to figure out the expected value of W, or the other we can say the expected value G plus B, if we want to figure out the variance of W, we can say the other situation, the variance of G plus B. So it means 3 1 over 4. It means it's here. And it means 15 over 16, 15 over 16. And I want you to make a compare the expected of G value and the expected value, the expected of B value, then the expected of G plus B. if you notice that, this is 1 3/4 plus 1/2. So it means we can write here 2/4, and it means 2 5/4, and it means 3 1/4. Okay, and this is here, this is the same value. And if you notice that the variance, it means 11/16 1/4, 11/16 1/4. If we add to both value, we have 15/16. So we can also see this situation, and the expected W, it means the expected of G plus B means the expected of G plus the expected of B, and the variance of W or the variance of G plus B means the variance G or G plus the variance of B. It's the same. Okay. Now, if we have two independent random variable, we can write the expected value of added of them. We can write the expected value x plus the expected value y. If we have two independent random variables x and y, and we want to write and or figure out the variance of x plus y, it means the variance of x plus the variance of y. Okay, for example, excuse me, now we will pass the other section. What about yes. Okay, now what about multiplies or independent random variables? Multiplies or independent variables. Okay, suppose the numbers on the green dice are doubled and the numbers on the blue dice are tripled. So we have doubled, the green dice are doubled and the blue dice are tripled. So the table shows the possible outcomes of rolling both dice and adding the adding the scores. So as you remember, green means green 1 1 2 3, but blue 1 1 2 2. So these numbers related to 2G, these number related to 3B, so third we can say, and added 2G plus 3B, it means 5 5 7 2 plus 3 5 2 plus 3 5 4 plus 3 7 going on. Let the random variable D be such that 2G plus 3B, and from the table we can work out the expected of D and the variance of D. It means 8 and 5. Okay, now let's remember that the expected value of G and the expected value of B. Our expected value G, G, 1 3 over 4, 1 1 3 over 4, 1 1 over 2. Okay, 1 3 over 4, 1 1 over 2. Okay, now we want to figure out the expected of 2G plus 3B. Okay, now I can write these number 7 over 4. I can write these number 3 over 2. If I use the multiplication 2 plus 7 over 4, 2G it means, and 3 multiply 3 over 2, and it means, you know, 7 over 2 and 9 over 2, it becomes 16 over 2, and I can write 8 instead of the 16 of 2. So it's the same value. As you remember, the variance of G and B, 11 over 16, 1 over 4, 11 over 16, 1 over 4, the variance of G, 11 over 16 and 1 over 4, I can write 4 over 16, and if I want to 2G plus 3B, the variance of 2G and 3B, and as you remember, I can write this section, the variance of 2G plus the variance of 3B, and please remember that 2 double G affect the variance, and third B affect the variance. It means 2 square the variance of G, it means 9 square 3 square multiply the variance of B, and it means 4 multiply the variance of G, 11 over 16, and 9 multiply 4 over 16, it means 44 plus 36 over 16, and it means 80 over 16, and it means 5. So this section is 5. So we can write if we want to figure out the expected of ax plus by, it should be a multiplied the expected of x plus b multiplied the expected of y. But if you want to figure out the variance of ax plus by, you can you should figure out the a square the variance of x plus b square the variance of y. Let's make some example and practice about this section. For example, if you want to if you want to figure out the expected O 4x plus 3y. So you should figure out 4 multiplied the expected OX plus 3 multiplied the expected OY. But if you want to figure out the variance of 4x multiply 3y, you should figure out 4 square multiply the variance of x plus 3 square the 3 square multiply the variance of y. For example, if you want to figure out the 5x plus 6y, so you should write 5 multiplied the expected of x plus 6 multiplied the expected of y. But if you want to the variance of 5x plus 6y, so you should write 5 square the variance of x plus 6 square the variance of y. Okay, now we have an example. The following tables give the probability distribution for two independent random variables x and y. And x, these numbered and the probability of numbers, and the y and the probability of y. Draw a probability distribution table for the random variable s, where s means x plus y, and find expected value of s and variance of s. If we if you want to fill up the table, and this is situation 2 plus 0, 2, 3, 5 and 3, 4, 6. And if we want to the probability of both 2 and 0, the probability of both 3 and 0, so the probability of 2 0.2 multiply the probability of 0 0.6. Okay, now it becomes 0.12, and 3 0.3 0.6, it becomes 0.18. Okay, 5 0.5 0.6, it becomes 0.3. And both 2 and 1, the probability of 2 and 1, both 2 and 1. Okay, so 0.2 multiply 0.4, it becomes 0.08. And 3 and 1 0.12, 5 and 1 0.2. Okay, now the probability of s, where s means x plus y, so 2 and 3, 4, 5, 6. So for 2 means 0.12, but please notice that we have 2 3s, so it means both 3 plus 0 and 2 plus 1, 2 plus 1 and 0 plus 3, so or we have we should add, okay. Now 0.26, okay, 0.18 plus 0.08. We have 1 4, so it means 3 plus 1, we should write 0.12. We have 1 5, so 5 plus 0, so it means 0.3. And 6 for 6, it means 5 plus 1, it means 0.2. Okay, now then we should find the expected value s and the variance value s, or s. The expected value s means the expected value of x plus y. It means 2 multiply 0.12 plus 3 multiply 0.26 plus 4 multiply 0.12 plus 5 multiply 0.3 plus 6 multiply 0.2. It means 0.24 plus 0.78 plus 0.72 plus 1.5 plus 1.2. Okay, now I want to look at the results of these process. And this process means this process 4.2. okay, 4.2. And if we want to the variance of s, the variance of s means x plus y. It means 1.8. 1.8. We can figure out the figure out by looking at this table. Okay, now for b, draw the table distribution table for the random variable t, where t means x minus y and 5 the expected of t and the variance of t. But now in this lesson we have no time, so the next lesson I will go on the as solving this problem. For now, have a good lesson and have a good day.